Okay, guys, for today you need page 22 out of your math packet. Starts off with 2.2e homework, page 22. So today we're going to talk about graphs, tables, equations, stories, how they all relate to each other. So starting off with today's story, this context. Context means story. Gavin is buying tomato plants to plant in his local community garden. Tomato plants are $9 per flat. That's important, so I'm going to underline that, $9 per flat. A flat contains 36 plants. Well, this part is all going to be, it's just trivia, nothing we actually need for this problem. Consider the relationship between the total cost and the number of flats purchased. So whenever you have total cost, that usually refers to like what you're graphing on your y-axis. Okay, and if we're making tables, the left side is usually our x values, the right side is our y values. So I'm going to label this one cost or total cost. Okay, my x side is going to be the number of flats. Okay, so I can just write in flats, there's a short little space. And then I need to fill in this table here. I should always put in a 0 because it's important to see how the relationship is when you have 0 of something. If I have 0 flats, how much is it going to cost me? Well, in this case, you're not going to buy anything, so it's going to be $0. Okay, if I have 1 flat, so 1 flat is $9 per flat, so 1 flat is going to be $9. Okay, if I have 2 flats, 2 times $9 gives you $18. If you got 3 flats, 3 times 9 is 27. Okay, 4 times 9, 36. And last, 5 times 9 is 45. Okay, so now I have my table. I'm going to go down to and look at my graph. I need to graph this. Okay, so I need to label my axes. Remember, this is your x-axis, this is your y-axis. I need to label it in terms of what we're talking about, the story. So my x-axis refers to the number of flats. So I'm going to put down here number, I'm going to put some more detail into it, number of tomato flats. Okay, the y-axis, remember that was our cost. So I can put over here, this is going to be our cost. When we graph, we should always put a 0 there. And then I need to come up with an appropriate scale for my x-axis and an appropriate scale for my y-axis. And those aren't always going to be the same. So if I look at my x values, the highest value I need to get up to is 5. Okay, there's way more than 5 squares down here. So what I want to do is I want to try to stretch the graph out some so I don't have this like tiny little graph. Basically, we're kind of magnifying it some. So I'm going to say that every 2 boxes is worth 1. So if I count 2 boxes, there's 1. Another 2, there's 2. 3, 4, 5, 6, 7. So I can fit more than 7 on there. I only need to get up to 5. Okay, but that's better than going 1, 2, 3, 4, 5, and only using a small portion of your graph. Now the total cost. If I look at this, the highest number I need to get up to is 45. Okay, if I count all these squares, I'm going to see that there's 15 squares, which means if I take this 45 and I divide it by 15, you get 3. And for me, that means every little square means $3. Okay, now I don't want to label every square like 3, 6, 9, 12, 15, because you have a lot of numbers there. And look all kind of jumbled. So what I'm going to do, because each flat is $9, I'm going to label every 9. So I'm going to count up, so 3, 6, here's $9. Okay, so another 3. So 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, and the very top is going to be my 45. So there I have my graph kind of set up, ready to go. Next thing is we're going to start putting some points on that graph. Okay, so 0, 0, yep, that's a point. Okay, 1, 9, so I see 9 at 1 flat is $9. So I put my point there. At 2, it was $18. So go over to 2, up to 18. Then at 3, it's at 27. At 4, it was at 36. At 5, it was at all the way up to the top at 45. Okay, use your straight edge now. Connect the points. And then make a nice long line there. And don't forget, drop your arrows on the end to show that the relationship will continue in that fashion. Okay, so now that we have that, we're going to go over and come up with an equation. So the equation is always y equals. Okay, always y equals. And then we always put an x. Now remember, this right here is going to be our rate of change. Okay, so rate of change. So I'm looking at this graph here and I'm seeing, well, what is the rate of change? Well, the rate of change for this one, it's $9 per 1 flat. Okay, $9 per 1 flat. So your rate of change is always your y over your x. So if you have a 1, you should always use that to kind of figure out your rate of change. So you take the y, the cost, over the x. $9 over 1 flat. Okay, so this means 9 over 1. It just simplifies to 9. So I can put a 9 in there. And our equation doesn't need to have that label. It doesn't need to transfer the label over. Okay, we just put the 9. 9 divided by 1 is 9. In the back, so the back part of the equation comes from what we call the y-intercept. Okay, the y-intercept, or where it starts on the y-axis. And if you're looking at your graph, it touches the y-axis at 0. Okay, so technically, I could put like a +0 or a -0, but I wouldn't really leave it like that. I would clean it all up, and I would just say y equals 9x. Okay, so my equation for that is y equals 9x. Now the rate of change we just talked about, we said it was $9 per 1 flat. And what does that mean? Well, it means 1 flat of tomatoes costs $9. Okay, 1 flat of tomato costs $9. What's the y-intercept of your graph? We just talked about that as well. Our y-intercept, we say y-intercept abbreviated equals 0. And what does that mean? Well, for this problem, it means if you don't buy any flats, you don't pay anything. Something along those lines, like, well, 0 tomatoes equals $0, okay? So if you don't buy anything, it doesn't cost you anything. All right, now let's see, it says, well, let's look, how would you change the context? Remember, context means story. So the relationship between total cost and number of flats is C equals 12F. So what they're saying here, cost equals 12, and it's times, so 12 times F, so 12 times a flat, which they're basically telling you that the cost is now $12 a flat. So how do we change the story? We would say flats now cost $12. Okay, so to change that equation, we say flats cost $12, not $9. Okay, let's go to page 23. Okay, so page 23, we have a different story. Number of students currently enrolled at Discovery Place Preschool is 24. enrollment is going up by 6 students each year. So consider the relationship between the number of students, number of years from now, and the number of students enrolled. Okay, so here we could have table. We need to come up with our x's and our y's. And anytime you ever see something with a total, okay, that's going to be your y. And in here, the total is going to be, students. So we're trying to figure out total enrollment. So over here, we can just say just students for now, or total students. Okay, x is going to be years. Okay, so right now, currently, it is 0 years, okay? That's our starting point. So 0 years from now, our enrollment is at 24. Okay, but I look at this and it says enrollment is going up by 6 students each year. So that means 1 year from now, 24 plus 6, you should have 30 students. And if that pattern continues, 2 years from now, you should have an additional 6. So 30 plus 6 is 36. And that will continue. 3 years, 36 plus 6 is 42. 4 years, 48. 5 years, okay, 54. All right, so now we go to the graph, and we need to put our labels on it. So the x-axis, we could say this is the years. Okay, I always want to put a 0 there. And the y-axis, I can say total students. Okay, total students. Now I need to label my axes here with some numbers. So the years, I only got to get up to 5. Again, I got plenty of room here. I don't have to go every 1. I could skip. So every 2, 1. Another 2, there's 2. Skip, there's 3, 4, 5. Okay, and I can go further all the way up to beyond 7. Now I have 54. So I'm looking here. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I want to come up with an appropriate scale, I can take 54 and divide it by 15. Now, I know it's not going to be a whole number. So if I do 54 divided by 15, you get 3.6, which means I need to say like every box is at least 4. Okay, I don't want to say 3.6. That's just going to be too hard to think about. So I can say every box is 4 or every box is 5, and that should be enough to get me beyond 54. Okay, so you know what I'm going to do? I'm going to just say every box is 5. Just kind of make it nice and easy. And I'm not going to label every box being 5. I'm going to label every other one. So if this was 5, then the next one's going to be 10, and then 15, and then 20, then 25, then 30, 35, then 40, 45, then 50, 55, then 60, and I could get all the way up to 70 if I needed. So now I got my graph set up. Okay, so I come over here and I see my table, 0, 24. So I'm going to go up to 0, 24. I know this right here, this box is 25, so I'm going to go right before it. Put my point, 0, 24. Okay, at 1, we're at 30. So go up to 1. Oops, I made a mistake. That one should be down below here. I kind of misread that one. So my fault, that point should not be there. It should be down below there. Okay, at 1, we're at 30. So that's nice and even on the line. At 2, we're at 36. Go over 2, go up to 35, and just a little bit more. There's 36. Okay, at 3, we're at 42. So go over to 3, up to 40, and then almost halfway up to 45. Put a point. And then at 4, we go up to 48. So almost all the way up to 50, just a little shy of it, put a point. And then last 5, go up to 54. So there's 50, almost all the way up to the middle part. Oops. I think I need to wear my glasses. Okay, so now I'm going to connect those points together. And you'll see if we graphed it correctly, we should get a linear line. All these points, they should be pretty much in line with each other. Okay. Obviously, if you're a little bit off, that might be okay. Just kind of depends on where you're eyeballing those points at. So I graph it. There's my graph. Now I need to come up with an equation for that. And so I start off with y equals, always put your x in there. Now remember, our rate of change is how much it's going up or how much it's going down. And we know that the rate of change is 6 students every year. So that 6 is going to be multiplied by the x. Okay, it's a positive 6. It's going up 6. Okay, then the back part is where it touches the y-axis. And that's where we look at our 0. So if I'm looking at 0, I see it's touching at 24. That's a positive 24. So I'll put back here plus 24. Okay, so our equation is y equals, we get 6, there's 6 students times every year, plus 24. Okay, so we kind of answered some of our questions down below. What's the rate of change? Well, the rate of change is 6 students per year. Okay, what does it mean in the context? Well, it means every year the student population increases by 6. Okay, letter B, what is the y-intercept of your graph? So the y-intercept, again, is just where it touches the y-axis. And for us, it was 24. Okay, what does the y-intercept represent in this context? Well, 24 stood for the number of students that we started off with, okay? It's our jumping off point. It's the beginning point. So we say it's the number of students we started with, okay? All right, letter C. How would you change the context so that relationship between the number of years and number of students enrolled was changed around to y equals 40 plus 6x, which is the same thing as saying y equals 6x plus 40. Okay, so we want to change our equation from this to this. And if I do that, what does that mean in terms of the story? Okay, what do I need to change to the story to make this equation? All right, you guys go ahead and type that answer down. Okay, let's turn it over to the backside. On the backside, we need to come up with our own context for number 3. So here's a table. Here's the number of fish. It talks about time in hours. So something's going on here. At 0 time, there's 300 fish. But as time goes on, we see we have less and less fish. Okay, so right now, you guys go ahead and write your context for this table. Type it in. Okay, next, I want you to skip the graph for a moment. I want you to come over to the equation. You guys go ahead and you want you to type the equation in that you think would match the context and the table. Okay, so go ahead and type the equation. Okay, and that's where we're going to stop for today.